Great. Well, it's quarter till, so I think we should go ahead and get started. So welcome everyone all over the world, whatever time zone you're in. Ruth and I are calling in from the East Coast of the US. And David, where are you located?
I am in San Francisco's North Bay.
Oh, awesome. Okay, so we have literally folks coast to coast ready to answer your most pressing questions on AI and ML. So I'll go ahead and just welcome you to this expert Q&A. We are all three of us cloud advocates, and we're really happy to be here with you, at least virtually, and we're hoping you're having a great day so far. So here's what to expect for this afternoon's Q&A. I'm going to do a couple of team introductions. I'll have an open question and answer session, and then we have questions from you. I see already some in the Q&A chat, so just pop those into the Q&A, and we will be publishing those gradually, and you can always upvote the ones that you think are particularly interesting, and we'll try to address those first. And then we'll have a little closing ceremony. Lower the flag. So yes, how to engage. So go ahead and use the chat box to ask questions. You can post anonymously, or you can use your name. Questions will appear to everyone once approved, and you can upvote your favorites using a thumbs up. The experts will answer verbally. I'll try to read the questions, and then your two experts here will answer verbally, and we'll answer the most popular questions first. Etiquette. Please don't record this session. However, if there are some screenshots that come up that you want to take, just make sure those are not of people. So if you want to take screenshots of a link that appears, then go ahead and do that, but no people, please. We'd like to ask you please to help our moderators. That's me, help me. Don't spam the chat. And please adhere to the Microsoft Code of Conduct, which is right here. And I pasted it also as an announcement into the chat here. So I think you can all read that. And I'm sure you've seen this at least once today. If not, here it is again. So here's our Code of Conduct. Okay. So let me just introduce you to our fabulous experts. We have Ruth Yakubu. Ruth, do you want to introduce yourself?
Sure. Hi, everyone. My name is Ruth Yakubu, and I'm a cloud advocate at Microsoft. I specialize in advanced analytics and data, and also machine learning and AI. Been with Microsoft for about 4 years now, seemed like yesterday, and I am so excited to join this virtual build. It's a new experience for me.
It's fantastic. I'm going to be kind of moving people around on the screen, so hopefully I won't mess it up. It's very important to notice that Ruth's go-to snack topping is Nutella. I totally feel you on that one.
You can't go wrong.
You cannot go wrong. Well, you can kind of go wrong, but yeah. And then I'd love to introduce David Smith, who's a principal cloud advocate, and I'll go ahead and send you live.
Yeah, hi there, folks. As Jen said, I'm coming to you from San Francisco's North Bay. I'm a data scientist, and I've been with Microsoft about 5 years now. I specialize mainly in the R language, but I can also answer questions about the Azure Machine Learning Service, maybe a little bit of Python, and I also am quite familiar with the Azure Cognitive Services service.
I love cognitive services, so fun. So I'll just say hello, everyone. I pop into the chat here. Hi, everyone. My name's Jen, and I'm your friendly moderator. I'm a senior cloud advocate lead. I'm on the academic team, so you'll see me hanging out tomorrow in the student zone, where it's really happening. We are too legit to quit in the student zone. So come join us for all of our sessions with that if you're interested, if you're a student of any age. So I'm happy to be your moderator. I'm going to flip back to the desktop, and we'll just kind of pop back and forth as questions come in. I'm gonna change the slide to this one. Oh, so these are some things you can ask us about: cognitive services, Azure Machine Learning Services, scaling AI solutions. And I thought maybe we could start by taking a look at this little kind of grid of what machine learning on Azure kind of looks like. And do you folks want to talk through these slides a little bit?
Yeah, I can talk to that a little bit. I mean, one of the nice things about machine learning on Azure is that it kind of exists for developers at every kind of level. So if you're a traditional developer without necessarily having AI and machine learning experience, there's cognitive services there on the top row. So all you need to do is connect to an API, and you've got access to a whole bunch of pre-trained models for vision and speech and so forth. If you're a more traditional data scientist like me, you're familiar with programming in things like Python or R. We support those within the data science frameworks you see there. And also, if you're an AI engineer or a machine learning engineer, perhaps you're using TensorFlow, PyTorch, frameworks like that, we've got solutions there for you as well, particularly around the Azure Machine Learning Service. Then, of course, we have an entire framework for getting those models that you've developed into production applications, and then they run on the Azure Cloud Infrastructure, which provides you with everything you need in terms of storage and also CPUs and GPUs to make it run as fast as you need.
That's awesome. You stopped talking just as I was going to sneeze.
Caught you right in time.
Sorry about that. Okay, there are quite a few questions coming up here. So everyone can kind of look through some questions and pick up and just vote for your favorites. I'm going to start with the most generic question that came here, which is a good one. So I'm going to shout out to Fabio. As a newcomer to the AI world, where should I start and what language is worth dedicating time learning? Ruth, do you want to take a shot at that?
Sure, I can take that. So when you're new to AI on Azure, there are a lot of things you need to take into consideration. Personally, I always tell people, try not to reinvent the wheel. Kind of like what David mentioned, we have cognitive services, and those services are produced by our researchers at Microsoft over the years. And a lot of those services are used in production before we even make it commercial. So I'll say check that before you start anything. The next thing is I like to figure out what level of expertise people have. If you're brand new to machine learning, you haven't built any models, we have an awesome service called Machine Learning Designer, and that's with no code. You just drag and drop, and you're able to train your models. You're able to cleanse your models, but you see the whole thought process of actually implementing machine learning models, and you can also produce REST services out of it. The third one is, let's say you're experienced, you're in between or advanced data scientist. That's when you need to go into our machine learning workspace. And with that one, it does support the notebook route. So if you want to write your custom machine learning experiments, you can use the notebooks. And our notebooks support Python and R. So depending on what type of analytics you're doing and what language you're more comfortable with, a lot of people use Python, but if you're using statistical type of algorithms, you can go the R route. I'm sure David, that's his area of expertise. He can elaborate on R. So that's an area where you can start. Then finally, if you're in between a data scientist and somebody who is trying out, you can also use our auto machine learning. And I think it's pretty awesome because a lot of us data scientists, we have a problem. We know, okay, this is going to be a regression type of problem, but there's so many different algorithms. There are so many parameters that we need to set. And as you're running the model, it may take 8 hours. And after 8 hours, you notice, okay, this is just a 30% accuracy. Then you start something else, tweak it and whatnot. So with auto machine learning, you're able to run a whole bunch of different algorithms, and it tries different parameters and comes up with the best model that you can pick out of that whole experiment. So We definitely have a lot for any data scientist or anybody coming into machine learning to try out and get started with.
Excellent. I always like to think of AutoML as machine learning for machine learning. It's very meta and it's very awesome. Here is an interesting question. I know there are SDKs available to use for ML. I've experienced some of them, but most of them require an Azure subscription. So if I want to use cognitive services, does that need a subscription? Maybe David is our cognitive.
Yeah, I can take that one, Jen. It's a really good question. And probably best if I break that up into two parts. And the first is, if you're a developer or an AI engineer that wants to work directly to train models with the Azure services, or to build an application that's going to connect directly to cognitive services, then yes, you absolutely do need an Azure subscription. You need to authenticate yourself into the service. We need to bill you for the services that you use. So we need to identify you to do that. So yes, got to get an Azure subscription to do that. By the way, an Azure subscription is free. You only get charged for the services that you use, and many of those services are free for developer volumes. So if you're just playing around with it, most of the stuff you might want to do is free. And even then, if you go to azure.com/free, you can actually get a new subscription. You'll get $200 in credits for free that you can use. Second part of the question, though, is what about your users? If you've built an application that connects to cognitive services, or you've built a machine learning application that connects to an endpoint from a model that you've deployed, do your application's users need to have an Azure subscription? And the answer to that is no. They're going to effectively be using your Azure subscription to connect into the service where that's needed. Or in the case of cognitive services, in many cases, you don't even need to connect to Azure at all because they can be run in containers directly on the device, as can the custom models that you build with the Azure Machine Learning Service. So you as a developer, you need an Azure subscription, but your users of the applications you build on top of that, they don't need an Azure subscription. Great question. Hope that answered it.
Fantastic. So here's sorry, go ahead.
Yeah, to add to that, kind of like David mentioned, with you don't really need a subscription, but especially for cognitive service, with the link that he gave, the free products under Azure, cognitive service is one of the services that's offered for free for 12 months. So yeah, you do sign up, you have the $200 credit on file, but you're not going to be charged. But the good thing is you are going to be able to implement that. That's a common question that we do get for especially startups out there that are interested in using cognitive services.
So are both of you on the startup team? Ruth, you are, right?
And we're both on this.
That's what I thought.
Okay. On the startup team.
I'm over here, academic team is like the startup team. Okay. So here is a highly upvoted question. It looks like Azure Machine Learning Compute can only do GPU-based batch interface. Oh, inference, sorry. If we need at-scale, near real-time GPU inference using highly customized models, is this only possible through a custom container running on AKS? That's a very specific question, but it's very highly voted. So.
Yeah, I can take that one if you like.
Go right ahead.
First of all, Azure Machine Learning can use GPUs in other ways than the batch facility. One thing you might have noticed is if you've tried to create a compute instance within Azure Machine Learning, which is the interactive instances you'll probably be using for development, you can use our N-series virtual machines as the basis for that instance, which does give you access to the GPU. So if you want to train, say, a big model on Tensorflow or PyTorch, you can do that within the compute instances just fine. And the same applies to the build instances rather you create with that as well. You probably though mean in terms of inference for deployment. And there's several ways you can do that. You suggest using a container, and that in fact is a pretty common way to do that. You might be exporting your model in TensorFlow or PyTorch, and then running it directly within one of those runtimes in a container and giving that access to the GPU. One other option that is available to you, which is pretty new and was just only announced today, is Onyx Runtime. If you're not familiar with Onyx, that's a way of deploying models that you build in lots of frameworks, including TensorFlow and PyTorch, to a shareable format called Onyx. And the Onyx runtime will run on a GPU, and that's completely independent of Azure. You can run that in any environment where the runtime runs. check that out. Look for Onyx Runtime on GitHub to see all the details about that.
Fantastic. Okay, another highly voted question. AML pipelines versus Azure pipelines. Which one is recommended for production deployment? Freudian slip, sorry.
Can you repeat the question again?
Sure. AML pipelines versus Azure pipelines. Which one is recommended for production deployment? Azure machine learning versus Azure pipelines?
I can take that one if you like. I gave a talk about that, in fact, at the last series of Ignite the Tour conferences, which we did last year. I can find the link for you. The conference, the talk name is AI/ML 50. We actually went into that exact topic, how to use both Azure pipelines and Azure machine learning pipelines in an MLOps framework for developing machine learning based applications, then deploying them using standard DevOps practices. That's a long story, the short story of which is to use Azure ML pipelines for the model training. They handle the big data sets and things like that in a much better way that Azure pipelines do. But then use Azure pipelines for the CI/CD process. And of course, today you could use GitHub Actions for that same process as well. While Ruth answers the next question, I'll look for a link and I'll pop that into the chat so you can check that out.
Sounds cool. How about this one? For Azure ML, is there a roadmap or time frame for adding support to connect directly to the on-premises data gateway? Ruth, any ideas?
In terms of the roadmap, I have not heard anything from the product team. So far, all the experiments, yeah, you can do it on-prem and just connect to your configuration to the workspace and send all your metrics, logging and traceability, and register your models to Azure. But in terms of the connectivity with your on-prem resources, that one, I haven't heard anything. And I think it was something we'll have to check with the product teams.
Cool. Any ideas about form recognizer? There's a question about when will form recognizer be in GE? I really don't know. I haven't heard about it recently. Anyone know?
I do not know the answer to that question, no. We could have a look at the Azure roadmap. Let me see if I can find a link to that and see if that's been announced, but I don't think it has.
Yeah, I haven't heard a peep about it recently.
Yeah.
Can they elaborate on which region they need it for?
Maybe in chat.
Okay.
Here's a kind of an interesting question because I kind of like TensorFlow myself. Can we include something like TensorBoard in Azure ML? TensorBoard.
Yeah, I can take that one. There are actually a bunch of widgets which are provided with the Azure Machine Learning Service SDK that do a lot of similar things to TensorBoard. There are widgets, for example, for hyperparameter optimization, very similar to TensorBoard. So you can actually have a look at the models as they're converging, or sort of the little runs being terminated early because of the stopping criteria in the hyperdrive optimization. There are other widgets for having a look at models as they're deployed and so on and so forth. So it's kind of recreating some of the experiences within TensorBoard. But in fact, and this is a little known fact, you can actually use TensorBoard itself on top of Azure Machine Learning. Don't have a link to hand, but my colleague Seth Juarez, I've seen him do this several times. While the next question is being answered, I'll see if I can find that and pop a link in the chat as well.
Fantastic. Here's a really interesting question. I'm very curious on this one. Are Azure machine learning algorithms open sourced, or is Microsoft constantly maintaining them and updating them from time to time? I mean, I think they are maintaining and updating from time to time, but the open source nature of the ML algorithms, I'm quite curious.
I don't think any of our services under machine learning are open source yet, not that I know of. If anything, it's the other way around. We do support a lot of open source tooling and services like the Databricks, MLflow, and whatnot. But making our services open source, I haven't heard of that. David, have you?
Yeah, just to add to that, there we go. Looks like I'm up now. Yeah, so all of the sort of the pre-built models that are based on Microsoft data, like in cognitive services, as Ruth said, they're proprietary for obvious reasons. They are continuously updated. The only exception to that is if you do download cognitive services to a container, that model that you use is then static until you update it, obviously. But the Azure Machine Learning Service, the platform, is designed to work with all of the open source frameworks and all those open source AI models out there. You can run directly within the Azure Machine Learning framework. And that's the way Microsoft is publishing a lot of its advanced research. We had a bunch of announcements today, for example, about differential privacy, about confidential computing, about fairness in AI. The way we work now is all of that research and production code has now been released as open source GitHub repositories. And now they're plugged into the Azure Machine Learning Service as well. So when you have a look at the fairness tab that exists within Azure Machine Learning today, there's running open source code that you can look at and contribute to in GitHub.
Amazing. There is a very interesting question, which is kind of generic, so I'm curious how we can answer this one. Do you have a scenario to access data that's stored on-prem? I'm assuming within a machine learning context. And maybe that's more of a data-oriented question.
Ruth, you got some ideas on that one?
Migrating data?
Accessing it that's stored on-prem?
Oh, yeah. So in machine learning, we have a concept called data sets. Maybe this is where it falls under. Depending on the size of your data, you can have you can upload it into the Azure data store, especially even if you run your models on-prem, then publish it on the Azure workspace. You have a way of linking to your data source. So for traceability and trackability, let's say later on you're wondering, okay, we put this model into production. What were the details? What kind of data do we use? You can use that, especially when you're publishing your model. Trying to think other ways that you can potentially migrate your data onto Azure. I mean, data is data, no matter where it is, whether it's online, on your on-prem premises. Do you want to migrate it if it's a whole bunch of JSON file? Do you want to move it into a blob storage? Then link your data data set pointer to point to that, or do you want to move it, migrate it, let's say, into a MySQL database or Azure Data Lake, that sort of thing. There are many ways you can move your data into Azure and preserve it, depending on what type of use case the user is doing.
Cool. Here's a question, another roadmap question. What is the roadmap for sharing and collaborating models, code, and data across machine learning workspaces?
I can take that again. So it still goes back to the whole data set that Azure Machine Learning has. The good thing is, let's say you have like a whole bunch of data coming in. Some may be coming via streamline, some may be coming via batch process. And in between, you need to transform that data. It could be a big data situation, and you probably have to go to Databricks, cleanse that data, then store it somewhere. But when you store it somewhere, you may want to choose something like create a data store for it. No matter where you stored it, whether it's Azure Data Lake, Azure Blob Storage, whether it's MySQL, all of that's fine. All you need to do is create a data set, and the data set will just point to where the location of your data is. Then as you run experiments, you can publish it into production. But the good thing is, working in a collaborative environment, other people on your team can also utilize that data, especially when it's cleansed at that point. It's perfect for collaboration, that sort of thing, and also traceability. Azure Machine Learning Service has a way of, depending on what the data set is, you can see what different machine learning experiments actually use that model as well. So those are the good tracking and traceability that comes out of having centralized data to be collaborative.
So interesting. I'm learning a lot just listening along. I have a hot ticket for the startup team here. This is a very nice question. I like this one. Okay, what are the most common pain points or pitfalls when moving from proof of concept to product when working with Azure ML? Okay, startup team, let's go.
Yeah, do you want to take that? Your mic is off. Yeah.
All right, there, I'm unmuted now. I've got a very clacky keyboard, so I muted myself when I was answering your question and forgot to unmute. Yeah, but that's a really good question and a really common one. That's actually one of the things that companies big and small struggle with, is how do you transition from the R&D development phase of building machine learning models, data science models, statistical models, and then handing that over to a production team, which is typically a different group of people. Like on the one side, you're working with data scientists, statisticians, people that don't necessarily come from a production background, to traditional engineers that have a very different kind of sort of outlook on the way things get done. The answer, which again is a very short answer to a very long and detailed question, is have a machine learning operations process. That same link that I sent out earlier this morning is on that exact topic, is how do you work in teams where you need to go from that R&D environment to that production environment. It's all about the process, and it's all about how those teams work together. Now, one of the biggest pain points in that transition is transitioning between frameworks or languages. So perhaps going from R or Python to C++ on the other end. How do you deal with that transition? The way a lot of companies are dealing with it today is to try and avoid that transition at all and work in the same framework. On the one hand, you might have the lower level languages have higher level SDKs the data science team can work with, so you can stay within the same framework. And conversely, especially in the container-based environments that we have today, being able to run traditional data science frameworks like R or Python in production environments is equally possible today. It really depends around what your team needs to do, especially around your performance criteria and data size criteria, but find a framework that works for your application and try and minimize the friction that comes in that transition. But have a look at that talk I mentioned, AI ML 50, that goes into this topic in detail.
Yeah, for sure. I think we've got time for one last question, and then we'll just do housekeeping. I think we can use this one. What is the recommended solution to run Azure Machine Learning based on the data hosted in multi-clouds? And this scenario is they have data in AWS, Azure, and on-prem as well. So multi-cloud scenario, what is the architectural question? Ruth, do you want to take that one?
Yeah, I can take that one. Send myself to live. Okay, so this is a very good question. A lot of big companies face that, and especially startups that are dealing with a B2B type of solution that they're using multi-cloud. When you have data in more than one environment, especially outside of Azure, we have a service called Azure Data Factory. And Azure Data Factory, I like it because it's able to pull data from different sources and different clouds. So let's say you have data in Redshift, you have data in S3, all these different popular clouds. You can configure pipelines within your Azure Data Factory and just point where the data is and where you want to put it within Azure. And it'll seamlessly grab all that information. If you need to do any ETL processing in between, you can go ahead and do that and put it into your target location. So that's a very good tool in terms of bringing in data from other premises. Other situations is, okay, if you have like one product, let's say you have MySQL in AWS or maybe Google Cloud, that's perfect. We do have also migration tools for individual type of services that you can do a one-on-one type of migration over. Let's say S3 to blob storage, but a cleaner, more optimized way of doing things, especially in a data science type of scenario. Azure Data Factory is a very elegant and very powerful tool to go about doing that.
Fantastic. So I think that takes us to the 15 after mark. So I'll just post up these few slides. I'd love to invite, we had 43 questions and they were all excellent. There was no fluff, all stuff. It was good. So very nicely done. So here is a couple of little housekeeping things. Please connect with us on Twitter. Revo David is David, Ruthie Yakubu is Ruth, and I'm a Jen Looper. So please connect with us. We're always happy to continue to chat with you. And that's it for us. So thank you so much. Don't forget to fill out the survey. So we really appreciate all of your time. Thanks, everyone.
Thanks for all the great questions, everyone.
Thank you. Enjoy build.